we'll talk about the chi-square test. Uh, this is required because t-test is mostly based on probability. Here we'll talk about the observed sequence and the expected occurrences. It is mostly based on the confusion matrix. Based on confusion matrix, we have lot of metrics which works on or evaluates the model. Here we have the Pearson's chi-square test, which is based on the observations in terms of the expected occurrences. Now here we'll take a small problem where we'll say how the male female is associated with the preference of drinking coffee and tea. Here you have a null hypothesis which says there is no association, and then there is an alternative hypothesis which says there is a gender drink preference. Now the expected frequency would be the row total into the column total by the grand total. So for coffee, it is 40. The column total is for male, it is 40. Column total is 50. So we say 40 into 50 by the overall total, which is 100. And for tea, again, it is 40 by 50 divided by 100. And for coffee with female, it is again 60. The total female strength is 60 by 50 into 100. And the same goes for T. Now the next one is the observed preference, where you talk about the chi-square value. Now coffee with male is only 30. So and the observant expected occurrence is 20. So what we'll do is it is 30 minus 20 the whole square by 20, where you get the chi-square value to be 5. Similarly here again the value is 10. So 10 minus uh, 10 minus 20, you get the value as 5, and then it is 20 minus 30, 40 minus 30 the whole square. So now to sum up, the chi-square value is something around 16.66. You talk about the degrees of freedom, it is the total number of rows minus 1 into column minus 1. Again the degree of freedom is 1. Okay. Now with degree of freedom 1, sensitive of alpha value, the critical value applied is uh, something around 3.84, which will be obtained from a particular table. But for us, for our calculation's sake, if the table is not provided, or it is from the model which we evaluate. So if the table is not provided, we'll stop over here, assuming some value for as the critical value. You can whether we have to reject it or we should not. We should accept it. If the chi-square value is greater than this critical value, we'll reject the null hypothesis. Else, we'll accept the null hypothesis. With this, we'll come to an end. For your exam perspective, the tables are not given. Kindly assume the alpha value and the critical value. Okay, and based on that, based on your assumption, you can make a decision. If the table is given, you can take the value accordingly. Thank you, ma'am.